Hello friends, welcome back to my channel. After a long time I am appearing with you. Today I am going to discuss about a new chapter of chemistry, that is language of chemistry.
Start.
So, what do you mean by language of chemistry? Language of chemistry means what is chemistry made up of? What do you think chemistry is what made up of? Formulas, chemical equations, and so on. So what is a chemical equation? Equation is a representative of a reaction. So we have to understand first what is the chemical reaction. So the chemical reaction is the process in which one or more substances called the reactants are transformed into one or more different substances called the products. So here a chemical reaction is in which two substances are mixed together and they form a new substance called a product. So, in a chemical reaction, it involves the breaking of existing bonds between two atoms or groups of atoms of the reactants. This means that when, for example, I am telling 2H2 plus O2 equals to 2H2O. 2H2 plus O2 2H2O. 2H2 means two volumes of hydrogen and one volume of oxygen. So 2H2O means four molecules of 4H means hydrogen and two molecules of oxygen. This means it is balanced. So from hydrogen 2 from oxygen 1 combine together to form a new substance, that is called a product. Okay, so this is the chemical equation. So now there are many more characteristics of equation. First I will explain that, then I will go to different parts of the characteristics and explain each line by line. So characteristics of a chemical equation or chemical reaction, there are 5. Change of color, change of state, evolution of gas, formation of precipitate, evolution of heat. First I will discuss about change of color. So here change of color is copper carbonate equals to copper hydroxide plus carbon dioxide. Here gas is evolved. Here gas is means it is released out. So here copper carbonate CuCO3 is break down into CO plus CO2. That is, copper carbonate is green in color. When it is heated, it turns black. That is copper oxide, and carbon dioxide gas is released. Here Cu, one volume of copper, one volume of copper, balanced. CO3 1, CO3 3, C1, C1. Here O is 3. Here O is 3. Sorry, here O is 2. How? Because here is 1 O, here is 2 O. 2 plus 1 equals to 3. Now, change of state. Change of state means liquid will change to gas or gas to liquid, like this. For example, C, that is carbon, that is in solid, and sulfur, which is two volumes of sulfur, that is also solid, when mixed together forms carbon disulfide, that is CS2 liquid. Now evolution of gas. Evolution of gas means gas will be released, that is effervescence. So but first I'll tell you what is effervescence. Effervescence is the formation of gas bubbles when one reacts with the other to form gas bubbles which will evaporate. For example, here Fe means iron plus sulfuric acid H2SO4, when combines with both each other they form ferrous sulfate plus hydrogen, that is evolution of gas. It is released out. So the most important part we are entering, that is formation of precipitate. So first I'll tell you what is a precipitate or what is precipitation. Precipitation is a process in which when one metal combines with another metal, they form insoluble substances which settle down as precipitate, and that is signed with the help of a down arrow. So here I have given an equation. Here ferrous sulfate plus sodium hydroxide, that is 2 volume of it, combines with Na2SO4. See, I have used color to symbolize Fe red color, Na2 2Na, SO4 SO4, OH2 OH2, and last, that is, I am telling the full equation, that is ferrous sulfate plus sodium hydroxide equals to sodium sulfate plus iron 2 hydroxide, that is dirty green PPT, means precipitate, that will form a dirty green color. Now evolution of heat, that means heat will be evolved. There are two types of this reaction, exothermic and endothermic. Here exothermic reaction is a reaction in which a chemical reaction where heat will be released, and endothermic is which heat will be absorbed. So now I will explain you some important things. For example, this one, electrolysis of acidified water. When you add 2-3 drops of acid to water, it conducts electricity. I will explain you with this chart. 2H2O, that is 2 volumes of water, when pass electric current through it, it forms 2 hydrogen molecules plus 1 oxygen molecules. Here pure water is a poor conductor, we already know. When water does not conduct electricity, so it is also poor conductor. On addition of dilute acid to water, the acidified water conducts electricity. Hence, on passage of electric current through acidified water, it dissociates to 2 volumes of hydrogen gas and 1 volume of oxygen gas. So when we add 2 or 3 drops of acetic acid to water, it becomes acidified water and it starts conducting electricity. Now, this is the most important part, that is the Haber's process. This process is named after scientist Haber, who introduced this process. So here we have to understand the formula for equation first. Here it is used production of ammonia. Here nitrogen, that is N2 plus 3H2, means 3 volumes of hydrogen, when under pressure of 200 atmospheric pressure, means a lot of pressure is pressurized over these two. When it combined with 2, add the catalyst of iron, and at 450 degrees Celsius, then it compressed to form 2 volumes of ammonia, and this triangle represents heat, and also it is reversible change. So how it is formed, I will explain. When nitrogen and hydrogen in the presence of a catalyst finely divided iron, means iron, not chunks of iron, they are finely divided into powder. In the presence of a catalyst, finely divided iron is added at temperatures of 450 degrees Celsius, subjected to high pressure around 200 atmosphere, which I told earlier, forms ammonia gas. The reaction is exothermic. Here heat is evolved, and heat is given out. This plus triangle. This triangle is called delta. The above reaction is used in the manufacture of ammonia gas, which is known as Haber's process. Solid reactants and solutions are not affected by change in pressure. See, solid reactants, for example, here CES is solid, sulfate is solid, is not affected. Only gases, they are affected. See, hydrogen, this is a gas. Nitrogen, this is also a gas. When combined together, this also forms a gas. So only gas is when under pressure forms another gas. Now, I will tell you different thing. For this, I have to explain one thing. That is bases, weak bases, acids, alkali metals. This I will discuss now. So first is bases. What is bases? I know you cannot understand what is base called in Bengali. Now I am telling you, base means khar ba kharok. Here it forms alkali metals, means base helps alkali metals helps to form bases. See, I am telling you bases formula, some base metal formulas. Sodium hydroxide NaOH calcium hydroxide CaOH whole 2. Done. Then potassium hydroxide KOH, lithium hydroxide LiOH. See, in these four bases, they're all hydroxides. See, the main difference between a base and an alkali metal is base neutralizes, that is, base means hydroxide or metallic oxide, which neutralizes the acid, whereas alkali metals form soluble with water to form acids. That is the main difference. But both are told same in Bengali, that is khar or kharok. Another example, that is rubidium hydroxide, that is RbOH. RbOH. Then barium hydroxide, that is BaOH2. Now some weak bases. For example, pyridine. Pyridine's formula is C5H5N. And then what is sodium amide? Na2NH. Sorry, not Na2, NH2. These are weak bases or bases, and there are many bases. Now acids. You know all acids, I know. Hydrochloric acid, sulfuric acid, that is H2SO4. This is hydrogen chloride or hydrochloric acid. Phosphoric acid, H3PO4. Then what can we do? What else? Acetic acid, that is CH3COOH. Another example is carbonic acid. These are all acids. Now I'll tell some alkali metals.
Click.
Lithium hydroxide, that is LiOH. Then another thing is CSH, calcium hydroxide. Now some salts. NaCl, we know, normal salt we eat. Now blue white chol, CuSO4.5H2O, that we call Nil. Here Nil, we in Bengali use it in thongas. In the means at the beneath of thongas we use this blue vitriol so that germs cannot grow. Now calcium oxychloride. This is calcium oxychloride. Then potassium alum. This is a very big K2SO4.AlOH whole 3. Again K2SO4 OH whole 3 24H2O. This is potash alum. This is the most longest formula I have ever told you. Now sodium bicarbonate or baking soda, NaHCO3. This is also alkali metal, salts, sorry. Then washing soda, Na2CO3.10H2O. Okay. Now I'll talk about valencies. Okay. Valencies. Potassium, K1 plus. See how it is formed. When K minus 1 electron means it removes 1 electron, means donor accepts 1 electron, then it forms K1 plus. Minus minus plus. Now, negative. For example, oxygen. O2 minus. O minus 2 electron, plus electrons means it accepts. Plus minus minus. O2 minus. Okay? Now, some more. Hydroxide OH 1 OH 1 minus, then CO3 2 minus. These are all valencies, some variable valencies. Variable valencies are those where one or more metals have more than one valencies. For example, Cu 1 plus, comma Cu 2 plus also is there. Then aluminium 3 plus. Then iron 2 plus 3 plus. So these are variable valencies. Thank you for watching my video and spending your valuable time. And I hope I will make more videos in future. And I'm ending my video now. I hope you like this video. Hope like, share and subscribe to my channel, that is from Study Room. Thank you.